Hello guys, this is CodeNCode and this is video editorial for the problem minimum path sum taken from Leetcode. So the problem is simple. We are given a grid of size n cross m and filled with non-negative integers, and we have to find the minimum sum path starting from top left top left corner to bottom right corner, which minimizes the total sum. So basically you have to start from cell 11 and end at cell nm, and I haven't mentioned here the operation you can do from cell ij. Either you can go down or right. That's the only two possible moves there are. So starting from this cell, either you can go here or here. So starting from this cell you have to go here, and the cells you choose as path, the sum of the values should be minimum. So one of the possible ways is here, 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 here. So this is a valid path and the cost is 9 of this path. Now the minimum cost path is of length of cost 7, and that is this. You see the 7 cost path. So how to solve this problem I have already explained in lecture 11 of dynamic programming part 1. I'll be putting the link of that course in the description. So I'll be still teaching you how we'll be solving this problem. So to solve this problem, we'll be taking a DP array of size n plus 1, m plus 1. That is one extra row with one extra column. Now fill the whole extra row and extra column with infinity. Infinity means the a bigger number such that none of the paths can cost as much as infinity. So if you know all of the values can be, the sum of any path will not exceed 10 to the power 5, then 10 to the power 5 plus 1 is good for infinity. Anything above 10 to the power 5 is good for infinity, so that you can ignore these cells. These are filled with infinity, so that you can ignore these cells, and only this is the last cell in the input. So below the last cell and right to the last cell, because these are the only two possible moves for you, fill them with 0. So what we'll do, we'll initialize the last row and last column with infinity, except the two cells which will be initialized with 0, which are down cell to the last cell in the input and the right one. All of these two cells will be initialized with 0. Now we'll start filling the DP. Now all of this I have explained in the lecture 11 of dynamic programming part 1 series, so I am not going into it in detail. I'll just show you how to solve this problem. So we'll start filling the DP array row by row, starting from and by the column. We'll start from the last column and towards the 0th column, right? So we'll start from we'll start filling the last row, but from right to left. So first we will fill this cell. The cost of this cell is minimum of either right or down. Minimum of right or down is 0 plus cost of this cell itself. So cost of this cell is 1, so 0 plus 1 is 1. Similarly for this cell, either right or down, minimum of right or down is 1, so 1 plus cost of this cell is 2 itself, so 3. Similarly for this cell, right or down, right is 3 and down is of course infinity. Minimum is 3 and 4, 7, so cost of this cell is 7. So DP of ij actually tells you, if you start from this cell to reach the end goal is to reach the last column, bottom right corner. So if you start from this cell, reaching the bottom right corner takes 7 cost starting from this cell. So our answer would be this cell, DP of 1 1, or if you are working with zero base index system, DP of 0 0 then. So we have filled the n-1th row. Let's talk in 0 base index system. So this will be the n-1th row. Now we will go fill this row starting from right again. So for this, the minimum of right or bottom is 1, of course. So 1 plus 1, 2. Minimum of these two is 2. 2 plus 5, 7. Minimum of 7 and 7 is 7, so 7 plus 1, 8. Now this row, minimum of infinity and 2 is 2, so 2 plus 1 3. Minimum of 3 and 7 is 3, 3 and 3 is 6. Minimum of 6 and 8 is 6, 6 and 1 7. So you see, starting from cell 0 0, if I talk in zero base index system, starting from 0 0, reaching all the way bottom right corner, the cost is going to be 7. So we can directly return dp of 0 0 from the dp array, and this is how we'll fill. So if I show you the code, this is a problem 64 from Leetcode dynamic programming, minimum path sum. So first, if you see, this is the input array vector of vector, which is basically 2D array. So n would be the size of the array vector itself, and m the number of columns would be, take any row from the input and take the size of that. So you see, n is equals to size of array and size of ar vector, and m is equals to I'm taken as size of the 0th column, doesn't matter. So n is the number of rows, m is the number of columns. So we take a dp array of n plus 1 m plus 1, remember, one extra row, one extra column. After that we fill the last row and last column with infinity, right? Int max in C++ is defined as the maximum value or 32-bit integer can store. So this is kind of infinity for this case. So the last row and the last column are filled with int max, that is infinity. But remember, the bottom and the right of the bottom right, what we say, this, for this and this cell we have to fill them with 0, and that is what I'm doing here. This is all pre-processing. After that we'll start filling our dp array, starting from n-1th row, because I'm working with zero base index system. So starting from n-1th row, we'll fill row by row, but from right to left, and that is what we are doing here. dp of ij would be ar of I, that is the cost of that cell itself, plus minimum of down or right. So this is how we fill the complete dp array. After that your result is simply dp of 0 0, because I'm working with zero base index system. So this was how you solve this problem, minimum path sum, from Leetcode. So this was all for this lecture. If you have any doubt or query, of course you can ask in the comment section. So till the next video drops, keep coding. Thank you.